In this short video, we are going to look at WPA2, which is IEEE 802.11i standard for wireless communication with security protection. And it is commonly used now in all wireless APs, either at home or for enterprise APs. So we have seen in previous videos several security problems in WEP and WPA. The fundamental reasons of all these security problems, for all these security problems to happen, was a poor design of sharing a secret among all STAs and the AP that these STAs belong to. For instance, in WEP, you need a WEP key shared among all STAs and the AP. Hence, you cannot use directly this shared key to do encryption because it is easy to derive this secret key. So instead, for each frame you send, for each frame STA sends or AP sends, it needs an initial vector to indicate this vector is for this particular frame only. Unfortunately, that vector, that initial vector, is transmitted in plain text, so which makes all kinds of problems that we saw in WPA and in WEP. And in WPA, it uses authentication mechanisms, and it also generates transient keys, and which means that section key is available, is possible. However, because WPA was devised to reuse WEP chips, okay, so it still needs initial vector. So initial vector is still transmitted in plain text, which makes it possible for an attacker to launch a denial of service attack. For instance, the attacker just needed to alter the value of the initial vector, which will make decryption impossible at the receiving side. Okay, so now if we step back a little and think through all of these issues, and if we look at what WPA offers at the key generation parts, then we know we can just completely get rid of, using initial vectors, completely get rid of sharing a prior secret among all STAs and the AP. Instead, each SAT or each user of the SAT should have its own username and password with the authentication server AS, and of course links to AP. So this way, after a legitimate user is authenticated, then secret keys can be generated, pairwise master keys can be generated, then transient keys can be generated using WPA, and then a section key can be generated for a particular sections. And that section key is used to encrypt all frames for that particular section. So once that is figured out, then of course we just needed to determine what data encryption algorithm should be used. Okay, so WPA2 chose AES 128 to be its encryption algorithm. So that is the whole story of WPA2. Now let's look at some more details. Okay, so WPA was a rush solution to the security problems of WEP. Hence, it was still not as secure as we would like it to be, because as we said earlier, it still needed an initial vector, and that initial vector is still transmitted in plain text. So WPA2 overcomes this problem. So we already said that it uses AES 128 based on session key generated from transient keys. And transient key, of course, was generated by pairwise master keys, and those master keys were generated based on the user password after authentication is done by AS. So that means WPA2 keeps the authentication part of WPA, keeps the key generation part of WPA. It doesn't use initial vector anymore to generate per frame keys. Okay, and so once again, in WEP, a per frame key is determined by the initial vector concatenated by concatenated by the web key, which is shared among all STAs and the AP. When WPA2 was first rolled out, there was a bit of a problem of upgrading from WPA chips to WPA2 because they were not compatible. So WPA2 needs a complete new chip. So that was a problem then, but that wasn't a problem now because all the wireless APs available on the market, they all support WPA2. Okay, the key generation, as we said, is the same as WEP. In particular, it has a section key, okay, for each particular section, exchanged using four-way handshake protocol, and it's a 128-bit key, so that is for AES 128 encryption. So when we use data encryption algorithm, we need to figure out, or we need to determine what operation mode we want to use. So for MSDUs, for frames, using AES 128, it uses a counter mode to do encryption, and it uses cyberblock training mode to generate authentication code. Okay, so so we already saw this technique when we talk about authentication. So now let's just go over the with this. So with the encryption and then authentication and integrity check. So for encryption, we use AES-128 to represent this encryption algorithm. K is the section key. So MI is a fragment of a MSDU. And initially, you set a counter value to an initial value, and then increase the counter, encrypt the counter, and use the result to exclusive OR MI, and then you get a ciphertext CI. So that is encryption. And for the authentication, it uses a CBC mode. So we set the initial value CI, okay? So to all zeros, 128 many zeros. And then you do CBC, so you train the previous C, that's C sub I minus 1, exclusive OR MI, then encrypt this part, and then you get CI. So at the end, C sub K, okay, so the last K, C sub K is the integrity check value. So that is how WPA2 does encryption and authentication check. So if you want to summarize WPA2, then the easy way to think of it as WPA2 uses WPA's authentication mechanism and key generation mechanism, but it uses AES-128 in counter mode as encryption algorithms, and AES in CBC mode to generate authentication code for integrity check. So that's it. So this is a pretty straightforward standard after WEP, after all WEP and WPA went through. So we can now forget all of these initial vector things and web key things, right? Of course, ARC4 is not good, right? So we just don't worry about those anymore, and we simply use the we use authentication plus section key plus AES to do encryption and authentication code. Okay, there was one security issue in early days, which of course called rollback attacks, where the attackers tricks AP to go back from WPA2 to WEP, right? So we just the SAT can sort of trick AP saying that, oh, I don't support WPA2. Now let's use WEP instead. Then of course, all the security problems of WEP can then be exploited. And there were other weaknesses in AO2.11i, but they are not related to security mechanisms. This protocol used, okay? So instead, they are based on this RSN protocol. So which means that there was some kind of loopholes in four-way handshake that may be exploited by the attacker, who can forge a message with wrong ISN, IE, and then disconnect STA from AP. So which means this is a denial of service. And the next is also a denial of service attack. You just deassociate an SAT and an AP, again using a forged MAC layer management frames. So this is a forged message in a four-way handshake, and this is a forged message at the MAC layer, MAC sublayer, management frames. So both of these will have the effect of disconnecting an STA from AP. But as I said, so this is a not the security parts, not the security solution, not because of the security solutions, because of the data encryption solutions we use, but it's on the other parts of the AO2.11i. Okay, so that is the end of this video. In the next video, we are going to look at personal area network security. In particular, we're going to look at Bluetooth security and ZigBee